Does the sequence number of TCP packet headers wrap around? I was wondering, since the sequence number in a TCP header field is randomly chosen during the handshake and is gradually incremented as packets are exchanged, what happens after 2 to the power of 32 initial_seek_no transmissions? Does the sequence number wrap around and become 0, or is the initial value reused, or is a new connection initialized from where the previous one stopped?
It wraps around going to 0. According to RFC 793. It is essential to remember that the actual sequence number space is finite, though very large. This space ranges from 0 to 2 **32, 1. Since the space is finite, all arithmetic dealing with sequence numbers must be performed modulo 2 **32. This unsigned arithmetic preserves the relationship of sequence numbers as they cycle from 2 **32, 1 to 0 again. There are some subtleties to computer modulo arithmetic, so great care should be taken in programming the comparison of such values. The symbol equals means less than or equal, modulo 2 **32.
Does the sequence number wrap around and become 0? Yes. All the details can be found in the TCP specification RFC 793 Transmission Control Protocol. Sequence numbers. It is essential to remember that the actual sequence number space is finite, though very large. This space ranges from 0 to 232, 1. Since the space is finite, all arithmetic dealing with sequence numbers must be performed modulo 232. This unsigned arithmetic preserves the relationship of sequence numbers as they cycle from 232, 1 to 0 again. There are some subtleties to computer modulo arithmetic, so great care should be taken in programming the comparison of such values. The symbol equals means less than or equal, modulo 232. Source RFC 793 Transmission Control Protocol.
Yes, it does wrap around. You can read it on Wikipedia or on RFC 1323, which shows how to protect against wrapped sequence numbers. Let me quote. TCP timestamps are used in an algorithm known as protection against wrapped sequence numbers, or PAWS. See RFC 1323 for details. PAWS is used when the receive window crosses the sequence number wraparound boundary. In the case where a packet was potentially retransmitted, it answers the question, is this sequence number in the first 4 GB or the second, and the timestamp is used to break the tie. And PAWS uses the same TCP timestamps option as the RTTM mechanism described earlier, and assumes that every received TCP segment, including data and ACK segments, contains a timestamp seg.sval whose values are monotone non-decreasing in time. The basic idea is that a segment can be discarded as an old duplicate if it is received with a timestamp seg.tsval less than some timestamp presently received on this connection. In both the PAWS and the RTTM mechanism, the timestamps are 32-bit unsigned integers in a modular 32-bit space. Thus, less than is defined the same way it is for TCP sequence numbers, and the same implementation techniques apply. If S and T are timestamp values, S, T, if 0, T, S, 2 **31, computed in unsigned 32-bit arithmetic.
Fresh